Hello guys, in this video I'm going to go over and the behavior and asymptotes of functions. The reason that we have to study the limit is that because the definition of the derivative is in the definition of derivative the limit is used, and then so the derivative is just the slope of the tangent line. So we get the slope of tangent line as when we approach the slope of the secant line. So that's why um, the limit is involved in the definition of the derivative. So that's what we have to learn the limit. The other reason to learn the limit is that using the limit we can figure out the end behavior and asymptote functions. So I'm gonna go over just the second part, the ended behavior and the asymptotic functions. So to figure out the end behavior and the asymptotic functions, you need to know the infinite limits and the limits at infinity. Infinite limit is that the limit of a function as x approach finite number a uh, equals infinity or negative infinity. It means the f of x goes infinity or negative infinity as x approach a, and then probably a can be infinity or negative infinity. That is called the limit, infinite limit at infinity. But anyway, the limits at infinity means that the limit of f of x as x approach infinity or negative infinity equals L, this is finite number. So all right, so the we're gonna use we can find out the vertical asymptote using the infinite limit, and then we can figure out horizontal asymptote using the limit at infinity. So, but let me skip it. Okay, so we just look at the ended behavior and asymptote of the functions, just kind of the combining those vertical asymptote, the horizontal asymptote, those stuff. Okay, so we just see some real problems. So let's see example 3 quickly, and then we see the example the 4 slant asymptote. Okay, so all right. So example 3. So now use the limits at infinity to determine the end behavior of the following rational functions. But I'm gonna try to find out the not only just uh the horizontal asymptote, but also I'm going to find out the vertical asymptote. So I'm going to try to find out both of them if they exist. Okay. So see the problem B A. Okay. So f of x is defined by 3x plus 2 over x squared minus 1. So you see that once we get the rational function, not only just a rational function, but any function having the fraction, then you need to find out the number making the bottom one 0. I mean, whether just try to figure out whether or not there exists the certain number making the bottom one to be 0. Okay, why? Because those number cannot be the what cannot be in the domain. Okay, and then those number may be the vertical the asymptote. Okay, so now let's see the A. So first one, we're gonna evaluate limit at infinity. Okay, so then limit of a function f of x as x approaches infinity. Then you see that since this is just a rational function, which means then numerator is a polynomial, the denominator is a polynomial. So then we have to look at the degree of top and bottom to compare them. Since the degree of the bottom one is greater than top one, so limit at infinity goes to 0, right? So I'm sure that you know about this. So now then it means that the the what x what let me see y equals 0, that's the horizontal asymptote, right? So and then next one, what if x approach what if a limit at infinity, I mean limit of f of x as x approach negative infinity, still we're going to get same result. Okay, so 0. So the x equals, oh, sorry, y equals 0, which is the x-axis, must be horizontal asymptote. And that's how to find out what the horizontal asymptote. But what about the vertical asymptote? I told you. You see that x squared minus 1? If x is the in f of x, if x is 1 or negative 1, then the f of x is not defined. So then limit of f of x as x approaches 1 or negative 1, then that function goes to infinity or negative infinity, right? So x equals 1 and x equals negative 1 must be vertical asymptote, right? So using the limit at infinity, we can find out the vertical asymptote, horizontal asymptote, sorry. And then using the infinite um, infinite limit, we can find out the vertical asymptote. So you see that this is a graph of f of x, by the way. So you can see that the graph go as x approaches infinity, the graph goes to approach the x-axis but never touch. And then if x approach negative infinity, the graph approach x-axis but never touch, right? And then also as x approach the negative one, but either side, left hand side, right hand side, is I mean left hand side, x approach negative one uh, from the left hand side, then the graph goes to the negative infinity. Okay, and then it makes sense. You see, if x approach a negative one from the left hand side, then x squared minus one approach 0 but still positive because the I mean sorry, the negative, right? Okay, let me see. Sorry about that. If x approaches negative 1 from left hand side, then since x is less than negative 1, it means that x could be negative 1.5, negative 1.1, something like that. So then taking square must be greater than 1. So x squared minus 1 is positive. But look at the, what about the numerator? 3 times negative number plus 2. I mean, negative 1.2 plus 2. That should be negative, right? So negative over the positive is what? Negative. So the sign of f of x must be negative as x approaches negative 1 from left hand side. But that fraction, the approach negative infinity, not positive infinity, but negative infinity. And then the what about the x approach negative 1 from right hand side? Then x is less greater than negative 1, which means that x could be 0.9 or 0.999. So x squared minus 1 is negative, right? And the 3x plus 1 is negative. So negative or negative positive, right? So f of x is kind of blow up, okay? So doing like this, like that way, we can figure out the graph should be like this, okay? So this is how to find the vertical asymptote and then the horizontal asymptote using the limit infinity and the limit at infinity. Okay. So now next one uh, is slant asymptote, example 4. So determine the end behavior of function f of x. This. Okay. So okay. So first, yeah. So let's find the limit at infinity to figure out the horizontal asymptote. Okay. So now I mean, determine the end behavior means to find out the horizontal asymptote and then vertical asymptote. Kind of, we have to find out all kinds of asymptote. Okay, why? Because what is the asymptote? Asymptote is just the the straight line where the function graph of function approach as x approach infinity negative infinity. Okay. So it's really the crucial role. I mean, the asymptote has has crucial role to figure out any behavior function. Okay, so the limit of that fraction, rational functions right there, and the x approaches infinity, then look at this. This is a rational function, right? So, and then we just look at the degree of the top and bottom one. So the 2x squared plus 6x minus 2, this degree 2, and the bottom one is 1. So what? This goes to infinity, right? Okay. So the f of x goes to infinity as x approaches infinity, kind of blow up as x approaches infinity. And then similarly, limit of f of x as x approaches negative infinity, it goes to negative infinity. Okay, it makes sense, right? So then the graph, okay, so means that there is no horizontal asymptote. There is no horizontal asymptote. What about the vertical asymptote? Yeah, -1. Look at the look at the f of x, the bottom one, x plus 1. So if x equals -1, then f of x, I mean, as x approaches -1, then f of x goes to infinity or negative infinity. We'll see. So we evaluate the limit of the what f of x as x approach 1 from left hand side, then x approach 1 from the right hand side. Okay, but doing that, let's see. Yeah, as x approach, this is the graph of the f of x. So as x approach -1 from left hand side, then 2x squared plus 6x minus 2 will be, should be, I think, a positive. Okay, just plug in negative 1.2 into the top and bottom one, but definitely the sign on the bottom one is negative, but I'm sure the sign of top one is also -2. So the f of x positive as x approach -1 from left hand side, and then the as x approach the -1 from the from the right hand side, and the sign of f of x is positive, so negative, so graph goes down. But you see that this one, that line is neither the horizontal asymptote nor vertical asymptote. That asymptote is called the slant asymptote. It's kind of oblique, right? How can you get this? All right, so then I told you from here we got this. The from the when we evaluate limit of f of x as x approaches infinity or negative infinity, we just got the infinity, negative infinity. But when you do this, just we have to take a look at the f of x. If the degree of top one is greater than bottom one, or greater than or equals, okay, degree of the top one is greater than or equals the bottom one, then you need to um, the what simplify the rational, that rational function. Okay, so what that means, make the degree of top one to be less than degree of the bottom one. Okay, so then let's see, give me a second. Yeah, so we actually using the synthetic division or ordinary division. Okay, divide the numerator by denominator, then you're gonna get this 2x plus 4 minus 6 over x plus 1. Okay, so then as x approaches infinity, and then we evaluate limit as x approaches infinity and negative infinity. Then as x approaches infinity, then 6 over x plus 1, definitely this fraction approach what, infinity, 0, but 2x plus 4 goes to infinity. But before going to infinity, think about this. X approaches infinity, then the f of x, the behavior f of x will be similar to the behavior of 2x plus 4, because the f of x approaches 2x plus 4 as x approaches infinity. Okay, yeah, 2x plus 4 goes to infinity, yeah, definitely. But don't just look at the last scene of this this what this behavior as x approaches infinity. Okay, but just look at the just kind of the process, the how f of x approach infinity. Okay, so just kind of look at just the middle of the scene while x approaches infinity, then f of x will be, the behavior of f of x will be kind of the similar or resemble the behavior to x plus 4. So then, oh yeah, so then you can see now f of x is kind of approach the graph of 2x plus 4. Okay. And then as x approaches negative infinity, or so since 6 over x plus 1 approaches 0, so the f of x approach graph of the 2x plus 4. Okay, so we draw the 2x plus 4, which is this, and the x as x approaches infinity, the graph approach, the 2x plus 4, and then as x approaches negative infinity, the graph approach the 2x plus 4, and then there is a vertical asymptote. We got that, okay? So as x approach -1, the right hand side, left hand side, the graph goes up and down, okay? So combining all those results, that we can figure out the graph of the f of x roughly, okay, like this, okay? So that's for today. So keep in mind this: to find out in the behavior, you need to find out vertical, horizontal, and then slant asymptote. Okay, that's for today.